Hi everyone, and welcome to MathSux. This video is going to help you pass the Algebra Common Core Regents. So we're doing this one question at a time. Here is question 13. If the parent function of f of x is p of x equals x squared, then the graph of the function f of x equals x minus k squared plus 5, where k is greater than 0, would be a shift of... So basically we're saying that we're applying a transformation to our quadratic equation. So we start out with p of x equals x squared, and then we transform it into this other thing that looks like f of x, where it's x minus k squared plus 5. So it's in that standard form. So just a little reminder about what standard form of a quadratic equation looks like. It looks something like this, where it says f of x equals a times x minus h squared plus k. So just a little reminder of what everything means. Remember that this is a horizontal shift. And if you think about it, we are adjusting what we're doing to x. So right, we're subtracting from x. So if you're doing something to x, you're going to be moving right or left on the graph. And then here, this plus k, this represents a vertical shift. So if you notice here, we're adding to the entire function. So if we're adding to the entire function, we're going to be going up the y-axis. So if you look back at what we have here, we transformed. We went from x squared to x minus k squared plus 5, and they want to know what we ended up transforming this function by. So if we're moving a horizontal shift minus k, that means we're going to be going to the right k units. So that's a little tricky, because whenever if you're subtracting, you're actually going to the right when it comes to standard form. And when you do plus 5, you're going to be moving 5 units up. Now we need to look for the correct answer choice. So we're going k units to the right. So we have that, and then 5 units up. So our answer is choice 3. Number 14, which expression is equivalent to parentheses negative 4x squared close parentheses raised to the third power? So whenever we have parentheses like this, we're going to be distributing that exponent. So negative 4x squared raised to the third power, we're going to be taking this 3 and distributing it. So this is going to give us negative 4 to the third power, and then distributing this, we're going to multiply these two exponents together, 2 times 3. So when we do that, we're going to get negative 4, I'm just going to keep expanding this, negative 4 times negative 4 times negative 4. This gives us negative 64. And then x raised to the 2 times 3 will just give us x to the 6. So we have x to the 6. So this is our answer, choice 3. Question number 15. Which function has the smallest y-intercept? So remember the y-intercept. Remember the y-intercept is where the graph hits the y-axis. So also algebraically, it's always represented by this b, and y equals mx plus b, and when it comes to a linear equation. So remember that this is always the y-intercept. So now that we did a little review on that, we can go back and look at the different values of y-intercept we have here. So here we know, if we look over here, we see that the y-intercept is equal to negative 6 for choice 1, based on the y equals mx plus b. The b value is minus 6. For choice 2, we're going to look over here, because the y-intercept, the value of x is always going to be 0. So right here, the choice for the y-intercept is 1. If we go up here, we have the y-intercept is equal to minus 2. And then here on the graph, right here is where it hits the x-axis on this parabola. So if you look where that is, it's at minus 2. The smallest value of y-intercept we have out of all these, we have minus 6, minus 2, 1, and minus 2. The lowest value we have is choice 1 at minus 6. So that choice 1 is our answer. Question number 16. Which domain would be the most appropriate to use for a function that compares the number of emails sent, X, to the amount of data used for a cell phone plan, Y? So just a little reminder about what domain is on a graph. Domain represents all the X values on a graph. So they told us what represents the X values. It's the number of emails sent. So if we know that, if you remember back to what kind of numbers there are, integers include positive and negative numbers. So we wouldn't want negative numbers when it comes to emails sent, right? So we know that's not the answer. Rational and irrational, they go even beyond integers. They include integers under the umbrella. So they include negative numbers, and they start including fractions and radicals and all these different kinds of things that aren't necessary to measure the number of emails sent. So we know that's not the answer. But what can be used is whole numbers, alone whole numbers. So just straight up whole numbers can easily represent the number of emails sent. So if you're looking for more on this test, check out the next video coming up. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!